Good day, dear Chuti. In this video lesson, you will be guided on how to graph a circle on a rectangular coordinate system, given the center and a point on the circle. Example number 1. Determine the general form of the equation of the circle whose center is 3, 2 and whose graph contains the point 1, 2. Sketch the graph. In this video lesson, we will only be sketching the graph. Step number 1. Prepare the Cartesian plane and plot the points. Step 1.1. Label the coordinates. Our first point P1 is 3, 2. X1 is equal to 3. Y1 is equal to 2. Our second point P2 is 1, 2. X2 is equal to 1 and Y2 is equal to 2. Note, point P1 is the center of the circle. Step 1.2. Draw vertical broken lines at X1 is equal to 3 and draw horizontal broken lines at Y1 is equal to 2. Step 1.3. Mark the point at the intersection of the two broken lines, just like this. Step 1.4. Do the same for P2, 1, 2. Step 2. Compute for the radius. Always remember the distance formula, and that would be d is equal to square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now, we have a center HK and that would be point 1. So again, in this example, center is HK and that would be point 1. Therefore, the radius being the distance between the center 3, 2 and the point 1, 2 is using this formula. R is equal to square root of x sub 2 minus h squared plus y sub 2 minus k squared. Or simply, R is equal to x minus h squared plus y minus k squared. Now, this is our given. We have x equal to 1 and y is equal to 2 because our point along the circle is 1, 2. H is 3 and k is 2 because our center is 3, 2. HK. So h equal to 3 and k is equal to 2. Now substitute. R is equal to square root of 1 minus 3 squared plus 2 minus 2 squared. 1 minus 3 squared is negative 2 squared. 2 minus 2 is 0, so we have 0 squared. Negative 2 squared is 4. 0 squared is 0. So we now have r is equal to square root of 4 plus 0, and that would be r is equal to square root of 4, and r is equal to 2. Let's now use GeoGebra. So again, our center is 3, 2, and then our point along the circle is 1, 2. We have computed that the radius is 2. Let's see. So connect B and A and compute the distance. Is indeed 2. So again, the center is 3, 2 and the point along the circle is 1, 2. Finally, we're going to plot the points around the center. So plot the points located above, below, and to the right of the center. For the point above the center, the x-coordinate remains the same. Again, for the point above the center 3, 2, the x-coordinate remains the same because we're just moving upward. Okay, so the y-coordinate will change, the x-coordinate remains the same. So x equal to 3. So add 2 to the y-coordinate because we have radius 2. So y is equal to 2 plus 2 is 4. Again, our center is 3, 2. So the point above the center is 3, 4. Now for the point below the center. For the point below the center 3, 2, the x-coordinate remains the same as well. X equal to 3 because we're just moving along the y direction. So subtract 2 from the y coordinate because we have radius 2 and we are looking at the point below the center. So below, that's negative, right? So subtract 2. So y is equal to 2 minus 2 is equal to 0. So the point below the center 3, 2 is 3, 0. So again, center 3, 2 and the point below the center is 3, 0. So here in GeoGebra, the point above the center is 3, 4 and the point below the center is 3, 0. Now for the point to the right of the center. For the point to the right of the center 3, 2, the y-coordinate remains the same. Y is equal to 2 because we're just moving along the x direction. So the y-coordinate remains the same. So add 2 to the x-coordinate because we're moving at the right. So at the right means positive. So add 2. So x is equal to 3 plus 2, radius 2, is equal to 5. So the point to the right of the center is 5, 2. So the center is 3, 2 and the point at the right of the center is 5, 2. So again, the point at the right of the center is 5, 2. So let's now show the values. Right of the center 3, 5, 2. Above the center is 3, 4 and below the center is 3, 0. And finally, step number 4, complete the estimated circle by smoothly connecting the 4 known points. And we can also do that here in GeoGebra. So click here, circle with center through point. Click on any of the points. Thank you for watching, dear Tuti. You may now proceed performing some of the asynchronous tasks. Thank you.